Welcome to my greatest common factor video. So, um, okay, so in the past lesson, we have learned what in the world factors are. And so just to review, factors are just numbers that can multiply together to make the number you're looking for. So an example would be like the number 18. Okay, so numbers that would multiply together to be 18. And so we can think of 18 and 1, we can think of 3 and 6, 9 and 2. I think that's it. 3 times 6, 9 times 2. Yeah. Okay, so all of these numbers down here, these are factors, okay, of 18. So when I am thinking, so let's go ahead and we'll just make sure. These things, all of them, they are factors. Okay, these are factors. So when I am teaching you something this week called the greatest common factor, it's called GCF, it is exactly what it's meaning. Okay, so I actually going to work backwards. Actually, step one is to find the factors. Find factors. Pretty easy, which we did. Now, 2 and 3 are going to work a little backwards because we have to have two numbers in order to find some commonality, and then we're going to find the greatest one. Okay, so C stands for common, oops, and G stands for greatest, and I'll show you what that means. The hardest part about this, honestly, is listing the factors. So as long as you've mastered finding factors of numbers, this is going to be a breeze. Okay, so let me go ahead and let's do an example. So we are going to find the greatest common factor, okay, of the number 9 and the number 6. And then what I do is I make these little T-charts, little charts, okay? So on these lists, all I am doing is only look at one number at a time, just one cute little number at a time, and just list the factors. Don't worry about anything else. We are only doing step one, which is just list your factors. So numbers that multiply to be 9 are 9 and 1, or 3 times 3. That's it. There's no other set of numbers that multiply to be 9. Cool. Now let's look at 6. Numbers that multiply together to be 6. So we have 6 and 1, and then we have 2 and 3. I don't think there's anything else. No. So these cute little things are our factors. Step 1 was just list the factors. That's it. All right, step 2, we'll do this in blue. Step 2 is find the common ones. So C stands for common. So I'm going to come over here to the 9 and the 6. I'm going to look at what numbers they have in common. Cool. They both have number 1 in common. They both have number 3 in common. Cool. That is all you needed to do. So we found the common ones, but GCF takes it a little bit further. GCF wants you to find the greatest common factor. So that's where step 3 comes in. Now, out of all of these numbers that are circled, which is the larger one? Well, it's pretty easy to determine here that it is the number 3. Out of all the numbers they share in common, 3 is the greatest. So the GCF here is 3. Okay, don't worry. We're going to do more examples. Okay, let's go to another one. I haven't found my colors if you can't tell. Okay, I want to find the GCF of 18 and 21. The GCF of 18 and 21. So the first thing I'm going to do is step 1, just list your factors. Okay, so we have 18, make a little chart, and 21. Or 20, don't mind me. 21. And again, if this video goes too fast, you just pause it, okay? Just you pause it, write this down, and then press play. So 18 and 21. Okay, so step 1, list my factors. Okay, so let's just look at 18. Two numbers that multiply to be 18. Well, I know 18 and 1, given. We did this earlier. 6 and 3, 9 and 9 times 2. I think that's it. I can't think of any more. Okay, so let's go over to 21. Let's think of numbers that multiply to be 21. 21 and 1. 7 times 3. I think that's it. Can't think of any more. Okay, so now we're just going to go down the list. Number 2, common factors. So what numbers do they have in common? I see they both have a 1. I see they both have a 3. This is turning me really similar. Picked a bad example, huh? All right, the very last step is, but I don't just want common factors. I want the greatest common factor. So out of the ones that they have the same, 3 once again wins as being the greatest number. So the GCF of this one is also 3. Doing good, right? Okay, let's do another one. New slide. Okay. Are you? All right, let's go ahead and I want to find the GCF of 20 and 8. The GCF of 20 and 8. Well, the cool thing about it, GCF tells you exactly what to do. It tells you exactly what to do, okay? So we have the number 20. We have the number 8. Right here it says factor. Okay, let's do factors. Step 1. Numbers that multiply to 20. Okay, 20 and 1. I know it's 10 times 2. 4 times 5. I can't think of any more. Right? I think that's it. Okay. The number 8. Let's think of numbers that multiply over here to be 8. So we have 8 and 1, 4 and 2. Is that it? Well, that's easy. Okay, so we just did the factor part. Now let's find the common ones. Okay. So step 2 is let's find the common ones. They both share 1. They both share 2. They both share 4. Okay, cool. Now we have all of these numbers that they share in common. Sometimes if you have so many factors, you really have to, you can list them if you want. That's perfectly fine. But I want the greatest, oops, sorry, wrong color. The greatest common factor, not just any factor, the greatest one. So out of all these numbers, definitely not 1. And then it's not 2. Hey, 4. 4 is the largest or the greatest common factor of 20 and 8. Isn't that cool? Not too bad. If any of these examples you want to see again, just go ahead and rewind this video and you can see it. So you're probably wondering why in the world we ever need to use GCF. And we're going to start doing this by simplifying fractions. So in order to simplify fractions, we need to divide the top and bottom number by a number that they have in common, by factors. Okay, so in this example, what they did here or over here, we do these little, I like the look of the T-charts, but you can also list the factors this way. They determined that the greatest common factor between 12 and 16, They listed all the factors and realized they both have 4 in common. Once they knew what the GCF was, they divided both the top and bottom by the GCF and simplified their fraction. That is why we learn GCF. It most likely is just used to simplify a fraction. So that's why they did this. So 12 over 16 simplified, they have to first find the GCF, which we learned for in all these cute little processes, and then they simplified fractions. We will push simplifying fractions more. We won't be doing it this week, but I just wanted to show you why in the world we learn GCF.